you going to video it?
Yeah, well, I'm sitting here with Nick, and we're going to have a running video on the presentation here.
This is my first Google Glass.
There you go. Hey, there's the first time for everything.
Video, yeah.
Fantastic.
Right. Here with Greg Evans.
Sounds good. So, I think you know the structure of TE. We're pretty much geographically diversified from the Americas to Europe, into Asia. 30-30-30 split. Big emphasis in China. So circuit protection has a 34-year-old history. Inventor of polyswitch and PPTC, you know the technology.
Right. It saves a lot of people stress.
Yeah, Raychem, a materials company, purchased by Tyco International, I guess in 1998 or so. And so, you know the story.
Right, exactly. Well, and frankly, it's a critical infrastructure.
Right. So our product line spans from over temperature to over current protection. We've got some integrated devices that we're packaging both over voltage and over current protection devices in one small form factor package, and then we've got an over voltage line as well, serving applications from battery to consumer electronics,
right,
to communications, automotive. A big emphasis of
automotive is huge right now. I mean, not even thinking about things like hybrid vehicles and autonomous vehicles, just the sheer fact of the massive amount of electronics in the automobile, even in a gasoline automobile, that need to be managed, maintained, protected.
Of course, but we do have that autonomous machine, sort of that robot in and of itself on our roadmap. I mean, we're watching.
Excellent.
As the electronification of cars continues to expand, that's the ultimate space, and there's just a lot of circuits.
There's a lot. Yes, sir.
And we're keeping that on our roadmap. So, our technology spans, what we'll talk about today is our RTP devices, the extension of our RTP 200 into a higher current application with our new high current RTP offering. So, our contribution to protecting circuitry in the automotive industry spans over current, over voltage, and thermal protection.
Right.
As you just discussed, putting those circuit protection devices as a system to solve full-blown solutions.
Exactly.
Is what we're striving to.
Well, because it has to be a system. Once upon a time, you could pull individual pieces of a solution together and say, okay, here, I got something that works. But nowadays, the integration has to be almost seamless because you're shooting for 0.5% of efficiency gains. You're shooting for, everything's got to be so exactly dialed in. There's very little room for error nowadays.
Right, and in safety circuitry, there is no room for error. We like to think that, that random event is caught by our
exactly
insurance policies. And I do like the tat, by the way.
Thanks.
So in this particular example, we're expanding our RTP line to prevent the situation where a power FET might fail due to resistive heating. So a short may occur in that power FET and then draw very little current. And so the upstream fuse would not blow, but at the same time a hot spot could develop on the board.
That's a very good point, the thermal. Right.
We see this in ABS systems. I think that's part of the OEM mandates around thermal protection, all the issues that people have had with these various systems, including ABS.
Right.
So, it creates a hot spot on the board, creates malfunctions, and then the system fails. So our RTP system is a higher current version of our RTP 200. It's designed to meet AECQ standards, and it's compatible with surface mount technology.
Right.
Board manufacturing. So it's a very nice system that allows reflow assembly processes.
There you go, and that's also very important because when you're talking about a thermal device that can go through reflow, that's a really big thing.
Right, indeed. And we've designed this to have spatial separation between activation events versus assembly events. So the RTP 200 technology is suitable for lower current applications, and positioned a few of those types of applications here, and then the higher current applications such as ABS and spark plugs and different types of junction boxes are associated with this, with this protection device. Okay. And this is just the next step in our technology roadmap. What we're trying to do here is save assembly costs, smaller form factor, suitable for high temperature applications under the hood, and very nice system from a high current point of view.
Excellent. Okay, I see what you're seeing. I see it here.
So cool. I like.
Yeah, the mode of operation is after reflow. There's an arming link that gets deactivated with a current pulse. And so you burn this little arm.
It's like a sacrificial link.
That's
A
right.
little fuse.
So basically, you allow the link basically allows the system to survive the reflow, and then you disable the link, and then
Disable
it's
the link with an arming trigger of some sort, some kind of current pulse, and then it's ready to go.
very cool.
And the threshold temperature is typically around 210 degrees C.
That's a good temperature.
So specifications.
Right. Well, what we'll do is we'll what's the URL that they can go up to and get some information on
I
this?
have all of this for you on a
Okay, I'll stick it on the text under this video.
but there is a data sheet where we have a link to that on the information I'm sending.
Right. But they can find it probably from the TE Connectivity homepage too, if they had to.
Well, if you go to circuitprotection.com, that's a deeper link into TE Connectivity's circuit protection.
And that'll lead you to this stuff.
Yeah, you'll find.
Very cool. So circuitprotection.com.
Yeah, that's
Sweet.
how I would get it. Yeah.
So one case study is around ABS modules, where you want to put this thermal protection device as close to the thermal load as possible. So what we've done here is integrated this device through SMD processing very, very close to the point on the board where the temperature must be stable. We talked about how this little fuse gets activated, and very low resistance in line, 100 microohms, and high operating current capability.
Very nice.
So just an example of, I think there might be, putting it very, very near the connector. This was a particular case study where the OEM wanted it to be close to this particular connector, and we could design it to fit right on the board, very, very close. And just in summary, opens at 210 degrees C, compatible with lead-free reflow soldering SMD processes, low resistance, and ruggedized, robust, good for under the hood.
Very nice.
Applications.
The alternative technology is a thermal cutoff link. TCO,
Right.
And the problem with them, of course, is they have to be essentially soldered on separately after the reflow.
Exactly, because they can't survive the manufacturing process.
So it complicates the manufacturing, it complicates the quality issues. All those things are all attendant with having multiple manufacturing operations. So having
Exactly.
something that's an SMD part that drops on the board and gets handled just like everything else, it just makes the whole process more efficient
And cost effective.
Right.
and more at least the implication, and more reliable too, because you've got less things that can go wrong.
Fewer process steps, right, to mess up.
Yeah.
Excellent. Well, hey, Greg, Nick, thank you so much for the time. I really appreciate it. And
Our pleasure.
we'll be back again, talk about some more stuff downstream.
Good, good.